Hello and good afternoon everyone. Really pleased to be here at the Apidays NewYork 2025 event. I'm really pleased to be speaking on the Open API track. So my talk today will be Graceful Service Evolution, driven by open standards guided by contracts. A look at contract testing over the years as a technique to help guide building and maintaining long-living APIs. So who am I? I'm Yousaf Nabi. I'm a man who wears many hats, a developer advocate, an API technical evangelist at SmartBear, and a community shepherd at the open source project Pact. I'm an open source freeware and shareware lover, and you can connect with me in a multitude of different ways, GitHub, X, LinkedIn, or via good old email. And here's me as an Opticat. This talk is dedicated to my dad, Yousaf Nabi. He's the reason I'm in computing today and standing here before you. He passed away unfortunately just after I presented this talk in Apidays NewYork, and between doing this recording, one thing that will never fail to dislodge from my memory was a plaque he had on his computer room. Computers will never replace human stupidity. He had it in his room when he was training, and it's stuck in my mind ever since. So here's to you, Dad. So we'll start off our talk by saying let's consider everyone's perspective. If we consider our API like a football, everyone might be looking at the same ball but from a different angle, so they can see slightly different things. Your consumer might be like, I can't believe you broke the API again. And the provider's like, I can't believe that change affected that consumer. They shouldn't even be using that field. So it may have been a situation you've been in before where you've had some pain either as a consumer or provider, but if we can take a more holistic view of our APIs, we can think about APIs without consumers being a wasted technical effort. Being able to understand those consumers' needs, especially when proposing a change, means we could have more targeted and meaningful conversations with affected consumers, and this allows our unaffected teams to work without impediment, which is really essential when we're dealing with large microservice-based estates. So what are the challenges today that currently face engineers delivering long-living, gracefully evolving APIs? So we'll take a customer quote here. So we have a very large program, many different Scrum teams. They're building a wide variety of components, all operating in a microservice events-based architecture. They're finding testing inside a highly volatile set of integrated environments is extremely challenging, and they're looking to gain better confidence. Their estate is complex, between direct calls to RESTful and GraphQL APIs, between using messages with AWS EventBridge or Kafka, or using third-party SaaS or partner integrations. The general gist of it is difficult to manage. Now this customer, if you're empathizing with this customer, please know you're not alone. Industry insights show that more microservices, the rapid expansion API growth is leading to more microservices and more protocols. 61% of teams are saying that most API growth comes from microservices. 81% of companies are operating in a multi-protocol environment, and 57% or more are using 3 or more protocols. And these quite old pictures from some kind of brand name internet services show that even with what might seem like a small number of services, kind of 450, 500, they build up complexity significantly, and they can often be called microservice death stars. And what are some of these headwinds of microservices sprawl as we try to, or companies try to race to deliver microservices? So there might be a lack of experience or skills. Your developers might not have had prior experience developing microservices, and as we saw from that microservice Death Star, there's an ever-increasing complexity of these systems. It's very hard to keep the mental load small enough for single or small number of engineers to kind of keep in mind, and there's increasing demand on speed of delivery and ever more pressed and limited time due to the engineers' workloads. And it's not just small organisations, mature organisations are feeling this pain as well. So I'll start by asking you a question. Where's your single source of truth? Is it your API description? Is it your implementation? Maybe it's stored in Confluence. Maybe it's one of the revisions that have gone through via email. Or maybe you have a different source of truth. And where do you store that source of truth? Is it a a VCS provider? Is it a centralized store? Or maybe it's some kind of third-party tool. So some of the problems that can derive from having a single source of truth or not having a single source of truth is provider drift. So provider drift is a phenomenon whereby your API implementation does not match the API description, and can be one of the quickest ways to alienate prospective consumers and cause friction in their onboarding process. There is some automated testing, API testing, that can be driven by leading API specifications such as OpenAPI or Async API, but over the years it's been a bit of a mixed bag, which can lead to developers crafting their own tests. And these own tests that developers craft may drift from the actual code and implementation, further compounding this problem of provider drift. And you might say, well, we have an API description, and our API description is our contract. Well, myself, and our team at SmartBear would disagree. We would actually say an API description is not a contract. Schemas are abstract, but contracts are concrete. And that was a quote that was specified by Matt Fellows. He's a Pat2Core maintainer and a Pat2Flow co-founder. So we put forward the hypothesis that a provider contract is the component sum of your API description plus functional tests which exercise your API implementation to ensure that it matches up with the API description. These two artifacts constitute your provider contract. I like to think of it as a product called Ronseal. I don't know if this came across the pond, but they had an absolutely fantastic marketing campaign. Their product was called Ronseal Woodstain, and their branding campaign was it does exactly what it says on the tin. So if I can give you one piece of advice from this talk, is I implore you to be more Ronseal about your APIs. Ensure that your API description matches exactly, your API implementation matches exactly what it says in the tin. It matches that API description. However, your provider contract is only one representation of your API. Hurum's law states that with a sufficient number of users of an API, it does not matter what you promise in the contract, all observable behaviors of your system will be depended on by someone. So if you are unable to understand your consumer usage of your API, you have to assume that your entire surface area of your API is in use, and therefore it makes it very difficult for you to propose changes to your system, because as you change an observable behavior, that may be depended on by someone and you break their workflow. There's a great XKCD skit you can check out, it's number 1172, that says every change breaks someone's workflow. We'll provide some techniques to allow you to identify whose workflow will be broken when you propose some of these changes, and we'll talk about that a little later. So versioning is also very difficult. How do you determine whether the change you're making to an API is a major, a minor, or a patch? How do you deal with multiple code paths to support multiple live versions? And does your testing tooling, do you have tooling which looks at your previous to new API specifications in order to infer the version level? Is your tooling able to consider what a breaking change is to a consumer rather than a breaking change from an API description to the next? And when you do, if you are, for example, supporting multiple live versions, this can cause confusion to your customer base, both existing and new. Which version API should I use, and how long will those older versions be in use for, and therefore at what point do I need to plan for a migration strategy? And where you have public API consumers or IoT devices, these can actually be affected by disruptions, and as an API provider you may never know that you've actually impacted someone's workflow. So we mentioned breaking changes in our last segment, but it's not a dirty word in API development. Sometimes APIs need to change, it's a simple fact of life. It's very difficult to craft the perfect API on your first iteration. But if we're unaware of the consumed surface area of our API, we cannot determine who would be those impacted users and what would be an appropriate semantic version for the change we're going to apply. This limits our ability to propose effective change mechanisms, such as the expand and contract pattern, where you may add new fields, wait for consumers to start using that new field, and once all consumers are moved on to that new field, you can remove the old field safely. Or safe extensions, where you add new fields or new schemas, but you don't destroy existing properties. And it also limits our ability to deploy independently. And if we think about our microservice Death Star, that can be really problematic. Beth Scurry, the creator of the Patch Broker, a mechanism for exchanging contracts between services, she said, if you can't deploy your services independently, you've built a distributed monolith. This is the worst of both worlds. So please, whatever you do, if you are moving to a microservice architecture, please be able to ensure that you have a mechanism to deploy independently in order to allow you to respond to change effectively and quickly. And one of our final phenomenon is something called consumer's drift, and this is where Hurum's law comes into play. All observable aspects of your service will be depended on by someone. And without a clear view of which consumers depend on which behaviours, that can lead to testing bottlenecks. The majority of testing takes place in integration environments, which provide slow feedback loops to your developers who may have actually context switched onto some other piece of work. And integration environments themselves are large haystacks, which mean when services fail to communicate, it's very difficult to pinpoint the particular root cause of that failure. And as we mentioned before, it can lead to big bang deployments, because with these integrated environments, everything is tested as a whole. The only way that we can be safe is to deploy all services at once, so this is very costly and inefficient. Now, if we understand that integration testing is a bottleneck when we have a large number of services, we might choose to move that testing down the stack. So in the unit testing realm, there's something called component integration testing, and this is where we're testing a service boundary of where a unit of code is going to talk to another service that's external to our code that's under test. And what we often do is to use great unit testing principles of tests that run independently, they give us fast feedback, they're stable, they're easy to maintain. We'll actually use a mock version of our provider or a mock version of our consumer in order to simulate what their real life behaviours would be. The only problem with this is it doesn't give us the confidence to release. So we get all the great properties of unit testing, but we lose the confidence property that we get from integrated environments and testing services to talk to together. And that's because there's nothing to ensure that these mock applications that we're using actually will behave in the same way as the real ones. So this actually leads to a phenomenon called mock drift. So what can we do about some of these problems that we've heard? So back in 2006, Ian Robinson and Martin Fowler of ThoughtWorks kind of discussed a new kind of pattern. So they called it consumer-driven contracts and proposed it as a service evolution pattern. And we're going to take a look today at how that service evolution pattern actually allows us to build our services gracefully and evolve them over time. So what is contract testing? It's an alternative approach. So rather than testing our entire stack and all of the interactions beneath it, we look at an entire full stack journey, and we look at the individual service to service communication points between them, and we test each of those in isolation. This gives us a number of benefits. It's simpler. We're able to test a single integration at a time, and without actually having to deploy that full integrated environment or either of those two services that are in scope. We have no dedicated test environment, so we can run them on a developer machine, and that gives us this fast, reliable feedback that we expect from unit tests. And these tests scale linearly with the amount of microservices you increase to an environment, rather than your integrated environments where as you increase the number of services, you massively compound the amount of time that it takes to test and massively increase the complexity of the testing landscape. And if you're able to ensure that your services can communicate before deploying your services, you get that confidence that these services will be able to communicate in an integrated environment, which leads you to that microservice nirvana of being able to deploy services independently. So PACT is a contract testing tool we'll be talking about today, and it removes the need for complicated release coordination because we have static knowledge about a system's compatibility. So the scope of our consumer test, as we said before with the mock doubles, is we have a collaborator in our somewhere in our code base, and its job is to communicate with an external service and to hide the details of that external service such that it's presented in a consistent mechanism to our consuming application. PACT helps us on the consumer side by allowing us to make requests to our mock provider and send those results back to our consumer. But as a byproduct of running these tests, we generate a contract file or a PACT file. This JSON representation of the expectations the consumer will expect from the provider. These tests have all those great unit test properties. They run independently, they give us fast feedback, they're stable, and they're easy to maintain. And if we think about the scope of a provider test, we're looking at testing most of the application. We may choose to mock out external services or in-memory, use an in-memory database rather than a real database, but we're looking to provide some quite large confidence of our provider by testing right the way through adapters, services, through our domain logic, through to our repositories that we'll use to access our data. And on the provider side, a PACT mock consumer will read the PACT file or the PACT contract and replay each request against the real provider. PACT then compares the actual and expected responses, and if they match, we verified that the mock applications behave the same way as the real applications. That means the real applications should be able to communicate correctly when they interact in real life. So once we have these contracts for individual service to service communication, we need a place to store those contracts, so we need some kind of contract mediator. And for each service and iteration of each service, there will be verification results from the provider that will verify that contract. So we need to store those verification results. And by being able to store these contracts and the verification results, we can install this contract mediator as part of our CI/CD pipelines, and that can allow us to automate this contract testing, such that when we publish a consumer contract that requires verification, we can use webhooks to trigger a just-in-time verification of coupled services in a decoupled manner. So that contract will, a new contract that requires verification will trigger a CI/CD pipeline run of the provider in order to verify that contract. And that means these teams can query a matrix of verification results, they can track versions across environments, and that can allow teams to ask if they can deploy a particular service into a particular environment, or a particular version of a particular service into a particular environment. And that really is one of the great facilitators for the ability to deploy independently, because you know that services are going to be able to talk to each other and you have a central store of truth for those results. So the PACT broker is a mechanism for storing contracts known as PACT files, and they also store the verification results which can be queried. So here we can see the contract between food and animals. The latest PACT was published 2 minutes ago. It was last verified 2 days ago and it was green. It may be the case here that our latest PACT that was published has no content changes from the last time it was verified, and therefore our webhook event triggers will intelligently not trigger at this point, because the contract has effectively been pre-verified. And we mentioned earlier with the provider contracts are concrete and schemas are abstract. So these PACT contracts have a concrete representation of the contracts or the expectations that a consumer has on a provider application. So they're stored as JSON files, but there's a HTML renderer in the patch broker that allows you to have a bit of a human readable mechanism to view these contracts. And you can build your very own microservice Death Star. The patch broker has the ability for you to visualize your microservices state. So what does it look like in action? Because we're talking about how contract testing can allow for graceful evolution of a feature. So in this instance, we have a consumer that's looking to develop a new feature, so they run their contract tests, and that generates some contract files which they publish to a patch broker. They then run their Can I Deploy tool, which allows them to query their verification results, and the particular provider has never verified this contract, so it's not safe to release. Now, this provider, at the point of publishing the contract, the provider is able to, would have a webhook trigger that would trigger the provider's verification. In the Can I Deploy process, we're able to add some polling in place that allows us to poll for a specified period of time to allow the webhook verification to take place. This webhook verification takes place during the polling for Can I Deploy. It might be the case that the particular contract you publish, the provider doesn't need to make a change to accommodate that. You're using a new field that the provider already provides. The provider would need to verify that contract, but the Can I Deploy polling means that at the earliest opportunity that the consumer has feedback that they can deploy successfully, they are able to unlock their workflow and go through and do that continuous integration and continuous deployment into an environment. So in our case, our provider was developing a new feature and hadn't actually implemented the feature at that moment in time. So our provider at some point separately, because we know that teams are often not working in the same sprints in order to deliver a kind of unified feature. It might be that the provider team are implementing this slightly later. So they again run their tests, and when they run their test, it's going to query patchflow for any available contracts for this provider, and those contracts will then be verified against the providers running local instance of their service. Once all the contracts are verified against that provider, the packed tooling has a set of results, and those results are published to the patchflow broker or your patch broker. The provider is then able to query the Can I Deploy tool, and the provider is safe to deploy that change, because this particular change is a backwards compatible change. We're not changing anyone's existing tooling. We might be introducing a new field or a new endpoint. So but we know that by adding this new change in, our provider is compatible with all versions of the consumers. So any consumers that the provider may have, but also for each provider, any version that exists which is either deployed or released into any particular environment. So for example, if consumer A was deployed to production and test, we would trigger verifications against each of those. If a consumer B was only deployed to production environment, we would check the version that's in production environment. We also additionally check the main version on the consumer's main branch, because that would be the next version of their software that may be likely to be deployed. So once our provider has implemented that feature, our consumer is able to merge their feature. They run their tests again, which creates contracts, which are then published to a patch broker. The consumer is then able to run the Can I Deploy tool, and the Can I Deploy tool will return a successful verification result, because the provider has verified that contract, and because the interactions between the two services are valid and compatible, the consumer is told that they're safe to release. Now, that kind of mechanism of generating these contracts and verifying them against a real locally running provider can be prohibitive for some teams where they have a large number of consumers to smaller number of providers, or if they're already embracing things like spec first development, where all their changes that they make are proposed through API descriptions, API specifications such as OpenAPI or Async API, and the implementations must adhere to these descriptions. So Atlassian were a particular team who encountered this problem, and they devised some new open source tooling called Swagger Mock Validator, and that actually allowed the team to use an OpenAPI spec to check if it's a compatible subset of a packed contract file. Now, I wrote about how Swagger, as it was formerly known, and OpenAPI now, and packed can work very well to protect your API development workflows. I think I wrote this post back in 2019. And it actually really resonated with the packed and packed flow team as well. So they introduced something called bidirectional contract testing. This involves kind of two parts. So from the consumer side, the consumer generates the contract test file. So they could either use packed to mock out their provider, or they could convert their existing mocks that they already have into a packed format. From the provider side, the provider needs to upload to the packed system a packed contract, a provider contract. This provider contract is going to be the API description plus some test evidence to show that the API implementation matches the API description. Once these two artifacts, the provider contract and the consumer contract, are uploaded to the system, Packflow is able to perform a cross-compatibility check, which will check that all of the interactions within the packed consumer contract are a valid subset of the provider's OpenAPI description. We do plan to expand this into further provider contract types or provider API specification types. At the moment, the only compatible one is OpenAPI. Now, SmartBear acquired the Pact project around 3.5 years ago, because SmartBear could see synergy with the Swagger project and other projects in their stable that neatly aligned with the goals of Pact and contract testing. So for API development, where SmartBear provide a substantial set of tools around kind of all areas of the API SDLC, contract testing was a natural tool, and Pact was one of the market leaders. So if anyone is familiar with the Swagger editor, so editor.swagger.io, there is a commercial tool by SmartBear called Swagger Hub, and that actually allows designers now to incorporate contract testing into their design time changes. So when they are proposing changes to an OpenAPI specification, they're able to run the cross-compatibility check and visualize very quickly which consumers would be impacted by making that particular change. In this particular interaction here, we've made a change and we've done a cross-compatibility check, and we can see that our contract, the API description as it stands, is compatible with all existing consumers of this API. So that really shortens the feedback loop and will allow the API designer, if they do need to make a change that will impact anyone's workflow, to understand exactly whom they will be impacting and how, and be able to either propose a different set of changes or to go and speak to only the affected teams. And it would be remiss of me in any type of conference these days to not be talking about AI. So we now have something called AI augmented contract testing, which is part of the SmartBear Halo AI family, and this came from a large kind of customer demand and from experimentation with the existing LLM solutions around their approach to contract testing. So we have contract testing, which has been pre-populated with all of the great kind of contract testing knowledge we've gained over nearly, I think, going on 10-11 years of the PAT project, and it allows you to generate PAT contract tests using a number of inputs. So these can be your open API descriptions, allow you to minimize the drift that you might have from your contract test, maybe drifting from open API descriptions. It uses your code under test, so it can be very specific about the assertions that it provides and make sure that it's actually testing your client code and not, say, a fake HTTP client. You can use test templates in order to provide consistency, governance and standardization around the way that you write tests in your organization. And with any great kind of Elm tool, you might need to provide additional prompt context in order to generate things with particular nuances that make sense to your organization. So all those capabilities have been built in. But it doesn't matter if you're maybe not a fan of AI, you can still use the regular PAT consumer DSL as before. So I'm going to leave you with some tips and tools to improve your API workflow. First, I would say is create a single source of truth, and that single source of truth, in my opinion, should be your open API, your API description. You should use modern standards such as Open API or Async API, depending on your needs. You should leverage these to generate codes, tests, and human readable documentation where you can. But you should test your Open API description. You should test it to ensure that your API implementation matches that description, and that allows you to mitigate the phenomenon called provider drift. You should also create a developer portal. This provides a centralized location for your API descriptions and associated information that developers require in order to get on board. This will create pleasurable and memorable experiences for your consumers of your API, and they will end up inevitably becoming champions of your tool and can just do natural kind of word of mouth advertising for you. I'm going to just recap on this point again. Ensure that it matches the implementation. An API implementation that does not match the API description will quickly alienate prospective consumers and cause friction, and it may impact your bottom line if you have an API that you monetize. Any functional API testing tool can be used, some of which will take your API description as an input, allowing you to perform a coverage check. Schema Thesis was a great tool that can generate tests based off your open API description. It's open source. Dread was another one. It also provided this capability, but as of November 2024, the project was archived. There are some limitations, however, with these existing tooling, with polymorphism. Some of them have outdated spec support, so there's definitely room for a new emergent in this space. I implore you, if you do build something awesome, please make it open source, and I've provided some links to Schema Thesis and the Dread project for a bit of inspiration. Kin Lane mentioned this in his opening talk about standardization and governance being a key pillar to your API success, and it's one of my key tenets as well. So govern your APIs by defining and applying standards. And API specifications such as Open API or Async API are great at describing their respective supported protocol types, wherever they lack the ability to specify rules which are pertinent to your organization. Standardization and governance is a key part in ensuring teams can work autonomously with a set of guardrails in place to ensure that each team produces APIs which follow best practices set by your organization. Spectral and Vacuum are both open source projects that operate in this space, and they use either predefined or custom Spectral rule sets. If you go to the Spectral project, you can find many different rule sets that have been pre-created. There's some design ones, there's OWASP for security, so be sure to check them out because they provide either a great starting point, room for improvement, or just a bit of inspiration to help you start building your first custom rule sets for your orgs. And then I'd say understand the surface area of your API and its relation to its consumers. And one of the best ways to do this is to leverage contract testing. So enhance your existing component integration testing, output contracts which define the consumer's runtime behavior, and supply these to your provider teams to run prior to deployment. That gives API providers visibility into the consumer usage of their API, and also gives them the ability to understand impacted consumers by proposing those changes locally and executing those pre-existing contracts against it. And this will lead you to be able to have targeted conversations with consumers, with only the affected consumers, minimizing wasted time for people who aren't going to be impacted by that change at all. And ultimately we can ensure systems can communicate pre-deployment, which can minimize an entire class of defects from our integrated system and get us much closer to that idea of being able to deploy our microservices independently. So that leaves us with a number of challenges that we can potentially address. So breaking changes, by having that insight, we can use mechanisms such as expand and contract and safe extensions with field level insight that wasn't possible before. We can mitigate provider drift by implementing tooling that ensures our API documentation matches our API implementation, and that allows us to safely advertise our capabilities. We can minimize consumer drift by using contract testing, which minimizes or mitigates the need for versioning, potentially reducing code paths and provider complexity, while maintaining independent deployability, which is a key tenet for a good microservice architecture. And we can increase developer happiness by providing feedback at the earliest point in the chain when proposing a new change, and allow them to safely understand the impact radius of that change without affecting other people's workflows. And altogether, versioning is made much simpler. By having a clear view of our API usage, we can effectively reason about changes in our systems and ideally live in a version-free API world. So I'm going to say thank you for your time today. I'm been Yousaf Nabi of the SmartBear Developer Relations team. You can connect with us, as I said before, in a multitude of ways, either on GitHub, Twitter, although I don't use it that much, LinkedIn, or via email. And we have a newsletter where you can sign up. It's bi-monthly. It's called No Fluff, Just Real Stuff. And if you'd like to be added onto that mailing list, just drop us an email to the DevRel team at devrel@smartbear.com. So thank you very much for your time today. Feel free, if you have any questions, to connect with me offline, and can't wait to see you at the next conference. Thank you.